Acids and Bases by Arpit, Ronak, and Shawn. We will start off the presentation by talking about some of the properties of acids and bases that differentiate them. To start, both acids and bases are electricity conductor in a solution, meaning that they can conduct electricity. For example, lemon juice is an acid, and it can also conduct electricity by transferring the electrons in a current. Next, bases have a slippery texture, for example, soap, and it also tastes bitter, while there isn't a common texture for all the acids, but it can be said that the acids taste sour. When litmus paper is put into an acid, blue litmus paper turns red, while the red litmus paper remains red. On the other hand, red litmus paper turns blue, and blue litmus paper remains blue in a base. When phenolphthalein reacts with a base, pink color is produced in comparison to an acid, where acid remains colorless. When there is an active metal, also known as alkali metals, where there's only one electron in the valence shell, when these type of metals react with an acid, hydrogen gas is produced. On the other hand, there is no reaction with bases and active metals. When acids react with carbonate compounds, for example copper carbonate, carbon dioxide is produced, whereas there is no reaction between carbonates and bases. However, when ammonium compounds react with an acid, there is no reaction. On the other hand, there is a reaction between bases and ammonium compounds. Non-metal oxides form oxyacids such as sulfuric acid, whereas metal oxides form bases. When acids and bases are reacting with water, hydrogen ions are free with acids, while hydroxide ions are free with bases. On a pH scale between 1 to 14, anything under 7 is an acid, and anything over a 7 is a base. However, 7 is a neutral, for example, distilled water. Acids contain excess amounts of hydrogen ions, while bases contain excess amount of hydroxide ions. Some examples of an acid would be lemon juice, vinegar, soda, rainwater, apples, and tomatoes. Some examples of bases would be ammonia, drain cleaner, baking soda, and soap. Here is a video to get a better explanation of the differences between acids and bases and their properties.
So last time we tried making a video, Moby accidentally poured acid all over himself. He's in the shop right now, so I'll have to do the video alone. Dear Tim, what is the difference between an acid and a base? From Brad H. Well, Brad, there are several ways to determine whether a substance is an acid or a base. One of the most popular ways is using litmus paper. When you dip blue litmus paper into an acid, it becomes red. And when you dip red litmus paper into a base, it turns blue. For example, this piece of blue litmus paper, when tested in lemon juice, turns red. We now know for sure that lemons are acidic. When we test red litmus paper under soap, it turns blue, because soap is a base. Acids and bases also have specific properties you can identify them by. Acids, like this lemon juice, are sour, and bases, like this soap, are bitter. Soap is also slippery, which is another property of a base. Although these are safe to eat and touch, most acids and bases you wouldn't want to taste or touch, because they could be dangerous to your body. Oh, hi Moby. Shouldn't you be back in the shop? Hey, it's not my fault. I told you not to play around with the tetrasfolinic acid. No, don't! I'm sorry. I shouldn't have. Moby, you shot a hole in the ketchup bottle.
Acid and base conjugate pairs. The diagram on the left shows the conjugate acid and base pairs. An acid's conjugate is basically the base formed when the acid loses a hydrogen cation. Similarly, the base's conjugate pair is an acid formed when the base gains a hydrogen cation. For example, the conjugate acid of hydrochloric acid is chlorine, and the conjugate base of chlorine is hydrochloric acid. In addition, the stronger the acid/base, the weaker the conjugate acid/base is. Acid and base conjugate pairs. The diagram on the left shows the conjugate acid and base pairs. An acid's conjugate is basically the base formed when the acid loses a hydrogen cation. Similarly, the base's conjugate pair is an acid formed when the base gains a hydrogen cation. For example, the conjugate acid of hydrochloric acid is chlorine, and the conjugate base of chlorine is hydrochloric acid. In addition, the stronger the acid/base, the weaker the conjugate acid/base is.
The three theories.
The Arrhenius acid-base theory. The Arrhenius acid-base concept classifies a substance as an acid if it produces hydrogen ions or hydronium ions in water. A substance is classified as a base if it produces hydroxide ions in water. This way of defining acids and bases works well for aqueous solutions, but acid and base properties are also observed and taken into consideration. Below, we also have some diagrams explaining and showing the process of how this occurs. The Bronsted-Lowry acid-base theory, which classifies a substance as an acid if it acts as a proton donor and a base if it acts as a proton acceptor. Acids are generally substances which lose their hydrogen ions, and bases are substances which gain the hydrogen ions when the reaction occurs. An acid-base reaction involves the transfer of the proton. Next is the Lewis theory made by Gilbert H. Lewis. The Lewis theory is a reaction of a Lewis acid and a Lewis base which produces a coordinate covalent bond, as shown in the image below, which I'll later explain. Coordinate covalent bonds are just a type of covalent bond in which one reactant gives its electron pair to another reactant. In this case, the Lewis base donates its electrons to the Lewis acid. When they do react in this way, the resulting product is called an addition compound, or more commonly known as an adduct. As seen in the image below, you see an A with a positive charge and a B with a negative charge. So, just want to explain the image a little bit. So in the image, you can see an A and a B. The A stands for the Lewis acid, which is a species that accepts an electron pair, therefore making it electrophilic, which means that they are electron attracting, and they have vacant orbitals. Next is the Lewis base, which is a species that donates an electron pair, making a nucleophile, which basically just is another way of saying that it attacks a positive charge with their lone pair, and they also have lone pair electrons, therefore making it a final product of AB with a coordinate covalent bond.
Acids and bases are categorized into two categories, whether they are strong or they are weak. The strength of acids and bases is determined by the ease in which they lose or donate hydrogen ions, also known as their ability to ionize fully when dissolved in water. An example of strong acids are hydrochloric acid, nitric acid, and sulfuric acid. Examples of weak acids are carboxylic acid and carbonic acid. Examples of strong bases are all the group 1 hydroxides, for example sodium hydroxide, and also barium hydroxide. Examples of weak bases are ammonia and amines.
To calculate the pH of an aqueous solution, you need to know the concentration of the hydronium ion in moles per liter. The pH is then calculated using the expression shown below. Here are a few practice questions.
Because you know I'm all about that bass, no acid. I'm all about that bass, no acid. I'm all about that bass, no acid. I'm all about that bass, bass.
base.
Yeah, it's pretty clear, I ain't no science fool. So you got litmus, well I can turn it blue. Make it go boom boom all over the place. When all the H plus meet all the OHs. Pink phenolphthalein, I think that's straight dope. Mix in a lipid here and it'll make it soap. You want it neutral, pH is low. Better set up a titration with a strong hydroxyl drop. Yeah, my lab tech, she told me don't worry about your eyes. If an acid gets in them, we just have to neutralize. You'll know I love me, my stomach, and all the things it dissolves. But my bowel that keeps it from eating my intestine walls. Because you know I'm all about that base, no acid. I'm all about that base, no acid. I'm all about that base, no acid. I'm all about that base, Ha! I'm gonna do the math to figure out the ratios to react. Stoichiometry, yeah, that's where it's at. And it'll tell you
To prepare at least 1 molar for your strong hydroxyl drop.
yeah, my lab tech, she told me don't worry about your eyes. Cause if acid gets in, we can fix it with alkali. You know I love me, my stomach, and all the things it dissolves. But my bowel that keeps it from eating my intestine walls. Because you know I'm all about that base, no acid. I'm all about that base, no acid. I'm all about that base, no acid. I'm all about that base, Because you know I'm all about that base, no acid. I'm all about that base, no acid. I'm all about that base, no acid. I'm all about that base, Ha! Ooh, 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 ooh.